It wanted me to sign in, which it never does. It usually saves it.
Yeah.
And it says that my username appears to be incorrect. If the problem continues, contact your support team. Well, I use the same password for everything now. Of course, I did leave my email.
All right, I'm going to snip this. And the reason I'm going to snip it is because I want to put it. I don't think we finished it. Somebody help me out. Did we finish this one? No, we're talking about this question on the board.
No, we didn't.
I don't think we did. So I'm going to snip it out. And I'm going to make it smaller, of course, but I'm just going to snip that out. Save as capture this PC. And then we'll get out of this, and pull this up right here. And
so funny, the other night I saw this video, this Hispanic lady who's looking at the following, so who's working.
we're not even going there.
A racist neo-Nazi, and the guy's like, I've been helping you guys out for 3 months now.
Have y'all noticed since the election everybody's racist? Everybody. No matter who it is, no matter what you're doing, you're racist. Just watch. All right, now why isn't this thing working? Pictures.
Ridiculous.
There it is. All right. Now I want y'all to set this up like we pretty much had it set up. It says Francisco needs to know the height of a tree, which is h, from a given point on the ground. He finds the angle of elevation, top of the tree, and he moves back. Now this is the way it's actually done in the real world. If you took, not the tree, but a water tank. A lot of times people want to know the height of a water tank or the height of a tower or whatever, and they can't measure it. So this is how you do it. You get an angle here, and then you step back 50 feet or 100 feet, and you get another angle. Now you've got two angles, and you've got two triangles, and that's what you want to draw. You want to draw the two triangles. They're going to be similar triangles. So we got one triangle that looks like this, and that's 36.7. And this is X, this is H, and we'll label this B, and label this C, and A. Then you got another triangle. And that angle is 22.2 degrees. And this is X plus 50. And this is H. And this is BCD. Now, you're going to be using these angles. So your little man is on that side. So you're talking about the adjacent and the what? Opposite. Don't have anything to do with the hypotenuse. So Oscar had a hump of what? Apple. So you're going to be dealing with what? What's of apple? Of apple. Of apple. The tangent. So the tangent I thought that was something mine up here. That's why I wasn't having a heart attack or anything. Okay, tangent of 36.7. I had a laptop one time when you started it up, it started doing that. You started going, and you had to sit there and wait. And then after you did it about 25 times, it stopped. All right, tangent of 36 is equal to h over x. and the tangent of 22.2 is equal to h over what? All right, now I want you to highlight this. I'll put a cloud around it, and then I want you to highlight what they have in common. What's the only thing that they have in common? They all have what in it? H. So that means you want to solve for H, for both of them. So go ahead and do that. I'm going to erase all this. But go ahead and solve these two for H. I think that's where we left off. Did we not? Okay. Mr. Barnes, Ms. Fuller, you still there? Mr. Barnes, you still there? I think my volume, this stupid speaker, that big gigantic thing right there that they spent $3,000 for.
Oh, do you know that like one of the classes we had last week, I remember you saying I want to make sure I got video feed.
Yeah.
When I went back to take notes on YouTube, there's nothing there. There's no video.
I know, because I didn't hit the present. That's why.
Because I remember you saying it.
Okay, Mr. Barnes, you still there?
Yeah, I'm still here.
Okay, Ms. Fuller, you there? Ms. Fuller. Okay. She'll come back eventually. There she is. All right, just want to make sure y'all still there. Want to make sure I'm recording. I am recording. And can y'all see the desktop?
Yeah.
Yeah, they can see the desktop. If they can see the desktop, then I'm recording okay. All right, let me get back to what I was doing. So, let me erase this. Now, do y'all understand why I'm dealing with the tangent? Does everybody understand that? Dealing with the tangent because you're only interested in the h and the x because that's the only thing given. You're not given a hypotenuse. So you can't get blood out of what? A turnip. They don't even acknowledge the hypotenuse on either one of these. So you know that the sine and cosine is out. Now, you could eventually find out what the hypotenuse is, and yes, you can use sine and cosine, but you can't. So you're going to be dealing with the tangent. So here we go. I'm going to multiply both sides by x, and that's going to give me x tan of 36.7 degrees is equal to h. Everybody with me? And then I'm going to multiply x plus 50 times tan of 22.2. Now, since these two are equal to h, what can I do with both of these equations? Anytime you've got two things that are equal to each other, what can you do to them? Set them equal to what? Each other. Remember that. Set equal to each other. Anytime. And that's one of the reasons you should have highlighted these h's right here. So, x tan of 36.7 is equal to x plus 50 times the tan of 22.2. All right, now, finish it. What are you going to do first? Well, you got two X's on each. You got X's on each side, so you might as well just quit, right? What do? Go back to pre-algebra and do this. 2x times 2 is equal to x times 3 plus 3 plus x, or whatever. That's exactly like this one, okay? Now this, you really can't do anything with. This one right here, you can't do anything. But what can you do here? Distribute. So what can you do here? What is the tangent of 22? What does that boil down to? I don't need the actual number, but it's a what? A number, right? So what do you do if there was a number right here? What if this was a 2? You distribute. You see, what happens is y'all see this and y'all go, it's a number, just like pi. Okay? So, I think we were getting to that point when we left last time. X tan of 36.7 equals X tan of 22.2 plus 50 tan of 22.2. Now, of course, what do y'all think we're going to do with that x? Tan of 22.25 or 22.2, whatever it is. Okay, what are we going to do with this? We want to get it on the other side. So how do you get rid of something with a plus in front of it? What? Subtract. So x tan of 36.7 degrees minus x tan of 22.2 degrees is equal to 50 tan of 22.2 degrees. We got x. What can we do with x? 2x minus 4x. What can we do with the x's? Factor out common term. Yes, that's right, class. Tangent 36.7 minus tangent 22.2 is equal to 50 tan 22.2. All right, now divide by that parentheses. I'm going to erase over here. So, x is equal to let's see if I can do this. Probably won't cooperate. It's close enough. So, x is equal to 50, 10, 22.2 divided by 10, 36.7 minus 10, 22.2. Now that's X. That's this guy. So you could actually plug that in and get this number right there. And then you could figure maybe, well, what's right here? What could we do? Didn't we solve this for H? Yes or no? Yes. H is equal to X times 10 of 36 point what? So what is this? Point at. What is this? X. But take that big conglomeration and multiply it by the tangent of what? So H is equal to X, which is 50, 10, 22.2 over 10, 36.7 minus 10, 22.2. All that multiplied by what? Tan of what? 36.7. So take your calculators and print that out. Make sure it's in degree mode. I'm sorry, what? 2 decimal places, distance, so make it 2 decimal places. I remember whenever I see something like this, when I was in civil engineering at Clemson, there was this engineering class you had to take. And all it was a 1-hour class, and it was how to use your calculator. And back then, it was HP, because everything was HP, everything. You brought a TI on Clemson campus, they bring you off Clemson campus. Now it's reversed. It's amazing how money talks, isn't it? Well, anyway, you took this class, and all it was they'd give you, each week, they'd give you like 10 problems on a piece of paper. And you only met one time a week. And those 10 problems made that look real small, and you had to punch all that stuff in to get the right answer. And the next week you get another 10 problems. So that's all it was. But anyway, that reminds me of having to do all of that just to get an answer. So what'd you get? I'm sorry, say it one more time.
0.9018.
The tree's not less than a foot. Not want to go back and try that again.
That was fine. I solved it for each start.
Okay. All right, what else did y'all get? All right, I got one person that says 20.1. Anybody want to confirm that? All right, there's 2. Anybody else? Let's see what without having to do too much work, let's go back to the thing here and see what they got. I'll make sure I did it right. Yeah. It's not 20 feet. You got 45? 5. Okay. So the answer is 45 feet. Now, this is a question I would give you on a test. Okay. We can give you a lot of them, maybe one. Let's say you had 20 questions on a test. I'm going to put probably 4 word problems on it. So this would be one of them. Okay? So you might want to flag that one in your notes. And why? Why am I picking it? Because on a standardized test, on a GRE, on a employment test, that is a question you could get. They love similar triangle questions on a standardized test. Okay? All right, let's do something else. I think that's it as far as this section. But feel free to send me one if you run into trouble, because the more we work on these, the next class, the better, because I'll be posting the test in the next class, and we'll be going over homework problems because I'm finishing up today. Okay? Yeah. Now, you can also, okay, this is just for your information. You might want to write it down. If you wanted to do it on your graphing calculator, just find where they intersect. So draw the tangent of 22.2 degrees x and the tangent of 36.7 and see where they intersect, and that's your, so you can do that also. Yes, sir. No, I won't drill you to, no. I don't do calculator drills because I don't want you to be dependent on it. Now, I want you to use it, but not dependent on it. And this is a use. Okay? If you know how to do this, you're not abusing the calculator. You know how to use the calculator. All right? This isn't monkey drills. All right? So if you want to, if you feel like you need to go through this on your calculator, just let me know. Okay? All right, so that's 8.4. So let's look at 8.5, if I can find it. And that should be, I thought I already had it down. Now, the good thing about 8.5 is, guess what? You already know it. How do you already know it? Because we went over it. Okay. 8.5 is circular functions, which is your unit circle. Remember when we first did the unit circle and I showed you how to do the cosine and the sine? There you go. Now, you're going to have to remember your special angles again. What are the special angles? 30, 45, and 60, Hubert. That's right, class. Appreciate the interaction. All right, right quick, I want each of you, don't go back in your notes, write down the special angles. Write down all 3 of them. And then I want you to start construction of a unit circle. Use a whole page so you can really draw it out. Draw your quartics, meaning your x and your y axis across it, so you can do your 0, 90, 180, and 270. Do those first. And then do the first quadrant with your special angles. So I'm just going to go to a whiteboard. Let me put it to you this way. If you can do your unit circle without having to regurgitate, just by learning it, just by doing it, then you've got half of 8.5 done. As soon as I can get it off of this, there we go. So I'm going to draw a unit circle. Darn, that's almost a perfect circle. Wait. Hey. And here. You can do blue here, straight line. All right, so we got 0, 2 pi. We got pi over 2. And we got pi and 3 pi over 2 down here. Okay, well, so let's start. What's first? Well, the x is first. The x is cosine. Cosine, comma, sine. Remember that. So, in the x direction on this guy, on 0 and 2 pi, x direction is what? 1, right? So what's the y direction? 0. So it's going to be 1, comma, what? 0. What about this guy? What's in the x direction? 0, oops, sorry. Yeah, 0, comma, what? 1. What's this one? -1, 0. And this one? 0, -1. All right, you're done with that. Now let's add the special angles. I'll write the special angles over here, and then we'll put them over there. So we've got, we're going to try to draw them. There's your 30. There's your 45. And there's your 60. And of course, that's 1 to 1 square root of 2. Now remember, this one right here, this is your 1. Now which one's bigger, 2 or the square root of 3? 2 is bigger, so that means this is square root of 3. 1, square root of 3, 2. So far I haven't remembered nothing. I have just what? Just learned 3 special angles. And I use my plotting, my graphing skills to tell me what these were. Now, here's my 30. My 30 is going right here. Okay, there's my 30. And we've got cosine and sine. Cosine. What's the cosine Oscar had? 1/2. Okay? I'm sorry. I just called a full rock at me. All right, now cosine, Oscar had a hump. Square root of 3 over what? 2. And you're done. All right, I want you to do 60. 45 and the 60. Take a minute and do that. And go ahead and tell me the radians too. Go ahead and fill out the radians for those 3. You know, that's 45 degrees, so that'd be pi over 180. So degrees are canceled. So that's going to be 45. This would be 30, 180. This is going to be 60, 180. So that's going to cancel here. That's going to be 3 over 18, which is pi over what? 6. And 45 will go in there like 4 times, right? Pi over 4. Somebody check on that there. And here, 6 will go in there. It'll be 3 pi, pi over 3. So 30 is pi over 6. And pi over 4. And pi over. All right, let's do our 45. We've got to do the cosine first. Oscar had a hump, 1 over square root 2, which is square root 2 over what? 2. Good. A hump, Oscar had, same thing, square root 2 over 2. Pi over 3, right here. A hump, 1/2. This is cosine. Oscar had square root 3 over what? And you're done. All you got to do now is remember all students what? All students take calculus. And remember the signs. I'm just going to put all students take calculus. And remember the signs. This is positive, positive. This is negative, positive. This is negative, negative. And this is positive what? Negative. So you got to remember when you're putting in. So now I'm going to take my angle and I'm going to put them right here. All right, let's start with, let me erase all this stuff. We know that this is the what angle? The 30-degree angle. What's 180 minus 30? 150 degrees. Well, let's go ahead and change that. 150, that's going to be 15 over 18, which is 5 over 6, right? Somebody help me out. 5 pi over 6? Check me. Is that right? 5 pi over 6. Let's go ahead and do 45. 45 over 180. We said that turned, or not 45. 45 from, is that 135? Yeah. So it'd be 135, 180 pi. So somebody crank that down. I don't know what is it, 3 pi. I'm sorry, what? That's what I thought. 3 pi over 4. And then somebody do the 60. The 60 is going to be 180 minus 120. So that's going to be 120. Okay, that would be 12 over 18, which is 2 pi over 3. Is that right? 2 pi over 3. And now we got those filled out. Let's go ahead and take our, we said this is what, 135? And this is 120. Okay, now the fun part. Cosine and what? Sine. Cosine and sine. I don't think I'm going to be able to do this, but I'll try. When did my microphone turn on?
I don't know.
My mic never turned on.
I can hear it now because my.
Okay. I don't know. Okay.
It's because I have it on in here.
Oh yeah, that's it.
When I walk out, it'll stop.
All right. So
I'm good.
this one gives you the circle right there. Just another example. Find the exact values of 7 pi over 4. First thing you're going to do is what? Now, if you know it by heart, then that's fine. You know 7 pi over 4, or 7 pi over 4 multiplied by 180 over pi, and 4 will go into 18 how many times? 3 times or 4 times? 4, and that leaves 45, right? And the pi goes out. 7 times 45 is what? Well, 7 times 5 is 35. 7 times 4 is 28. 315 degrees. So, 315 degrees is 45, which we know that 45, the cosine and the sine are the same thing. All students take what? Calculus means the cosine is what? Cosine is positive, and the sine is what? Negative. So what is and let's say you just forget, then draw your 45, 1 square root 2. Sine, Oscar had, would be 1 over square root 2, which is square root 2 over 2, which you know that's for both. See? You don't have to think too much, you just have to remember. Alright? Find the exact value of negative 5 pi over 3. Be careful here because they're telling you to go in the opposite what? Direction. They're telling you to go this way. Well, first of all, let's figure out what it is. 5 pi over 3, pi, 180, 3, 60, 300 degrees. So you're going to go, there's 90, there's 180, there's 270, and 270 plus what? So that means that's 60 degrees, right? Yeah, because this is 30 degrees. 30 degrees here, 30 degrees here. Okay, alternate interior angles. So that means we're dealing with what? Your 60 degree angle, and it's in the first what? So all means that your cosine is going to be positive, and your sine is going to be positive. So we remember our 60 degrees is 1, 3, square root of 2. No, 1, 2, no, 1, 2, square root of 3. I always get this mixed up. Here we go. Oscar had, so that's square root of 3 over 2. A hump. I didn't memorize anything. I just did it. Just like a problem, over and over and over. And let's check our answers. Did we get it right? Well, the first one we get it right, let's see what. Cosine and sine. Did I get square root of 2 over 2 and negative? Is that what they got right here? Square root of 2 over 2 and negative square root of 2 over 2. All right. On B, that looks different. Did I not do it correctly? Okay. Okay, opposite. Okay, Oscar had square root of 3 over 2. A hump. Oscar had a hump. Did I not? What did I get wrong?
Yes, retention, so that
Oh, I'm sorry. I didn't even read the directions. So Oscar had a hump of what? Of apples. So that'd be square root of 3 over 1. Square root of 3 over 1, which is equal to the square root of 3. Now, you got to ask yourself this. It's in this quadrant, so it's all, so that means it should be positive. I didn't read the directions, sorry. I was finding the cosine and the, yeah, there we go. The phase f of moon is given by blah, 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 where t is called the phase angle. F of t gives the fraction of the moon's face illuminated by the sun. Okay? And t is the angle. Okay, they're just going to ask you to put those in. Now, pi over 2 is what? 90 degrees. Pi. So they're not asking you to do a certain thing. They're asking you what? At the cortex. They're asking you here, 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 and what? Here. And what they're asking you to do, this half of this face right here is going to be open to the moon. This face right here is going to be open to the moon, or sun, whatever. This one right here is not going to be as bright, and this one right here is going to be like that. So you just plug and chug. So cosine of pi, or 0, cosine of pi over 2, and you don't even need your calculator because you know your unit what? Circle. And the cosine here is going to be what? 1. Here it's going to be what? 0. Here it's going to be what? -1. And here it's going to be what? 0. So 1 minus 1 is 0. 0 is going to be your answer here. 1 minus cosine of 0. 1 minus 0 is 1. This is going to be 1/2. And so on. -1. What's 1 minus a -1? 2. 2 times 1/2 is what? 1. So your answer is going to be 1 here. And this is 0. 1 minus 0 is 0. Or 1 minus 0 is 1. So that's going to be 1/2. So there I did it without a calculator or a unit circle, just doing it from memory. New moon. Oh, that's blue. There. It gives you 1/2, 1, and last quarter. Oh my gosh, we're through with Unit 1. Okay, so let's talk about something before y'all get out of here. All right, let's use this right here. And we got 2 minutes. So let me just do this right quick. Do this right quick. Okay, this is the Thursday. We will be going over homework problems that you send, which none of y'all have sent. So that means either you haven't done them or no, I don't want you to send me some just to send them. I want you to send them because you don't know them. Go over homework problems you sent. If not, then we will go over what? All right, if we go over the test Thursday, then that means I will date, test, and homework. That means next Tuesday, if we finish everything Thursday, Next Tuesday, I'll give you an in-class test. That in-class test that I'm supposed to give you that's just awful. Okay? That's going to be bonus points, basically. All right, so Thursday, if you send homework problems, I'll go over those. If not, then we'll go over the test. If we finish the homework and the test, then that means that I'll date the test that day. And that means the next Tuesday, we'll have an in-class test. Of course, your Thursday test will be going on. I mean, your online test is what counts. But I have to give an in-class test. So, if, let's say that you send me homework problems and we don't get to the test, and that means Tuesday, we'll go over the test, and then I'll put the dates on Tuesday. And Thursday, we'll have an in-class test. The in-class test will consist of questions from your online test, which is from your homework. Okay? All right. Anybody got a question on that? All right. Let me shut down Mr. Barnes, Miss Fuller, Miss Simmons. Y'all got any questions? I hope y'all can hear me now. But, okay, they're not talking to me. Miss Fuller left. Okay, see y'all.